On February 1st, 2003, the world watched as the Space Shuttle Columbia disintegrated as it re-entered the atmosphere after a 16-day mission. Debris was scattered over several states, which included the remains of the crew, Commander Rick Husband, pilot William McCool, mission specialists Michael Anderson, David Brown, Kalpana Chawla, and Laurel Clark, and payload specialist Ilan Ramon, the first Israeli astronaut. And like the loss of Apollo 1 and the Space Shuttle Challenger, the loss of Columbia and her crew stunned the nation. And for some Americans, it became a defining moment. Today on Revealing History, we take a look at some of the most shocking facts about the Space Shuttle Columbia disaster. On April 12, 1981, Columbia, STS-1, became the first space shuttle to fly into space. And this mission, commanded by former Apollo astronaut John Young, along with pilot Bob Crippen, marked the beginning of the space shuttle program. And there would be many more firsts for Columbia. In 1982, Columbia flew its first operational mission. In the following year, the first Space Lab module was flown into space aboard her, along with the first European Space Agency astronaut. In 1994, Chaki Mukae flew aboard Columbia, becoming the first Japanese woman to travel into space. And in November of 1996, Columbia set the record for the longest shuttle mission, which lasted 17 days, 15 hours. In all, she flew a total of 28 missions into space before she was tragically lost during the final moments of STS-107. And during the investigation of that incident, no potential cause, including terrorism, was discounted. When Columbia broke up during reentry on February 1st, 2003, the United States was in the early stages of the war in Afghanistan, the results of the terrorist attacks of September 11, 2001, which were still fresh in everyone's minds. And the U.S. was ramping up for war in Iraq, which would kick off in March of 2003. Terrorist attacks around the world were becoming almost a common occurrence. And to add weight to the possibility that the downing of Columbia was the work of terrorists, on board the shuttle was the first Israeli astronaut, Ilan Ramon. Despite the heightened security around Kennedy Space Center, even more than usual because of the heightened terrorist threat, it wasn't outside the realm of possibility that sabotage or even an act of terrorism was the cause. And even though it was a low possibility, it was something that investigators could not overlook. The investigation into the cause of the incident ultimately determined that a hole was punctured in the leading edge of the shuttle's left wing. And this resulted in damage to the vehicle's heat shield. The heat shield's primary function is to protect the orbiter from intense heat of atmospheric reentry, where temperatures on the underside of the vehicle can reach up to 3,000 degrees Fahrenheit. But despite the critical nature of the heat shield, re-entry simply isn't possible without it. The tiles were extremely brittle and prone to damage. Even minor impacts from debris during launch or in space could potentially damage or dislodge tiles, ultimately compromising their protective capabilities. And it was this precise scenario that led to the Columbia disaster. In what was seemingly a minor incident during the launch, the damage to the shuttle's left wing heat shield was the result of a piece of foam insulation that broke off the external fuel tank 82 seconds after liftoff and struck Columbia's left wing. The breach caused by the strike allowed superheated gases to penetrate the wing structure during re-entry, leading to the loss of sensors and ultimately the shuttle's breakup. In an eerily similar incident that occurred to Atlantis during STS-27, which launched on December 2nd, 1988, a section of insulating foam from the external fuel tank struck the belly of the shuttle, damaging 700 thermal protection tiles on the orbiter's right wing 85 seconds after liftoff. This impact caused significant damage to the shuttle's heat shield, and the shuttle's engines were shut off early as a safety precaution. Atlantis, which was on a top-secret mission, thankfully did not meet with the same fate as Columbia. The tragedy is, however, that NASA knew about the potential damage a piece of foam insulation could cause and did not take the necessary precautions that may have prevented the loss of Columbia and her crew. During a shuttle launch, there are cameras positioned everywhere to analyze the mission from start to finish. One of those cameras was on Columbia's belly and was designed to take photos of the external fuel tank as it was jettisoned and began to separate from the shuttle. The photos were used as part of the launch documentation so that NASA could note and correct any issues they found. Now, the standard operating procedure called for the photos to be transmitted back to the ground at the end of the first day of the mission. The crew was extremely busy that day, and the photos were never transmitted. Had they been, the engineers on the ground would have seen the missing section of foam insulation that was as big as a piece of carry-on luggage. Now, in addition to the cameras on the vehicle, there are numerous cameras set up along Florida's Space Coast to film Columbia on her way to space. The imagery analysis team began reviewing the footage the day after launch, and they were shocked at what they saw. At 81.7 seconds after launch, a large piece of foam was seen falling off the external fuel tank, striking the orbiter's left wing, and disintegrating into a shower of particles. And according to Ann Miklas, who represented the thermal protection system team during the investigation, quote, "People's jaws dropped. You could have heard a pin drop in that room when we saw the foam strike." Now, one might ask why foam insulation falling off was even a concern. And the answer lies in the vulnerability of the shuttle's design. The space shuttle was designed to be reusable. And exactly as the name implies, its primary function is to shuttle astronauts and cargo to space and back. And unlike the vehicles used during Mercury, Gemini, and Apollo, which flew to space at the front of the rocket, the shuttle flew to space beside the rockets, meaning that if debris fell off the fuel tank or rocket boosters, it was likely to hit the shuttle. And damage from a debris strike was one of NASA's primary concerns during the shuttle program. And while spacewalks had become a routine part of most missions, there was no procedure to effect repairs of the shuttle's exterior once it got into orbit. And as we mentioned earlier, the heat shield was extremely vulnerable to damage. And given that the shuttle's skin was made of aluminum, much like conventional airplanes, with a relatively low melting point, any damage to the heat shield that resulted in hot gases of reentry getting to the aluminum skin could be catastrophic. And on Columbia's 28th mission, it was. The natural question to ask at this point is what could have been done to save the crew? If after seeing the video of the foam strike, why didn't NASA do more to 1, determine the extent of the damage, and 2, try to repair the shuttle or rescue the crew with another shuttle? And 2 very good questions. And those questions were posed to NASA during the incident investigation. Before a cause of action could be determined, the extent of the damage had to be known. And once into orbit, all NASA knew was that a piece of foam insulation had struck the underside of the shuttle, a scenario that had occurred in prior missions. To assess the damage, engineers would have to inspect the shuttle's heat shield while in orbit. And there were 3 options to accomplish this. 1, through the use of imagery obtained by intelligent assets. And this option had been used prior to assess damage to a shuttle, ironically, Columbia on her maiden flight in 1981. But for some reason, this time, NASA refused to make a formal request to use the assets because administrators said that there wasn't enough data to warrant getting the intel community involved. Yeah, but isn't that the point of getting them involved? To obtain data of potential damage? The next option was to visually inspect the underside of the shuttle. And this could be done in 2 ways: looking out the window of the shuttle or via a camera. Well, since the damage was underneath the orbiter, looking out the window was not an option. So how about a camera? Well, there are no cameras on the underside of the shuttle. And the option to mount one on the shuttle's robotic arm wasn't possible on this mission, because it wasn't needed on this particular mission, so it wasn't on Columbia. And even if it had been, it couldn't reach the underside of the shuttle. And that leaves the last option, a spacewalk. Because of the configuration of the shuttle on this particular mission, dictated by the experiments that were to be conducted, a spacewalk would have been a 2-day process, and NASA, again not having enough data to justify the disruption in an already tight schedule, deemed it not necessary. But let's assume that they knew the extent of the damage and that the vehicle would likely not be viable to return home. What could have been done about it? The only two options were to repair it in space or send up a second shuttle for a rescue mission. Regarding the first option, a spacewalk to repair the damage, well, that's something that had never been done prior, and NASA wasn't even sure if a repair in space would even work. Now, while it could have been attempted, there are no guarantees it would have been successful. So that leaves us with the last option, a space rescue. Understand, though, that there isn't an unlimited amount of time in which to conduct a rescue. There were limits on how long the astronauts could survive aboard the shuttle. In the case of this mission, that limit was 30 days. And the main limiting factor was the supply of lithium hydroxide canisters used to remove carbon dioxide from the air. The next scheduled launch was set for March 1st, and it was to be on the Space Shuttle Atlantis. And the order was already being prepared for the mission at the time Columbia was launched. And if NASA had given them the go-ahead, Atlantis could have been ready to go by February 10th. This would have meant, however, that all unnecessary testing would have had to been skipped. The Accident Review Board determined that had NASA known the extent of the damage and had the preparations and launch of Atlantis been flawless, a rescue could have been attempted. But again, its success was no guarantee. And in the end, NASA managers convinced themselves that there was nothing to worry about. After all, similar incidents had happened prior to this one, and nothing happened. But why should this one be any different? It's interesting to note that Atlantis, the shuttle that would have rescued Columbia had the decision been made to do so, had experienced a similar issue during STS-27 and returned home safely. It holds the distinction as being the most heavily damaged spaceship ever to survive reentry. Columbia was the first shuttle to fly in space and the heaviest. Additionally, on this mission, it was carrying a Space Hub module in its cargo bay. And all that means is that STS-107 would be the heaviest orbiter to ever return from space. And it also meant that temperatures of reentry would be hotter than usual. And this became a major concern for some at NASA. But as before, most believed that Columbia would be heavily damaged, but would bring her crew safely home. The priority for most was getting Columbia repaired and ready for the next launch. So the decision was made that Columbia was a go for reentry. And on February 1st, 2003, at 0815 hours, Commander Rick Husband fired the shuttle's orbital maneuvering system, which would bring her out of orbit and on a path back to Kennedy's shuttle landing facility. The path back to Florida would take her over California, Nevada, Arizona, New Mexico, Texas, and Louisiana. As Columbia flew over California, flight controllers in Houston began to receive unusual telemetry readings. Temperatures coming from sensors inside the orbiter's left wing began to rise. Soon after, the sensors went dead. It was considered odd that all sensors would be lost at the same time. One maybe, but not all. At 0859 hours, Columbia was above Dallas, Texas. Commander Husband was communicating with Houston when in mid-word, communications stopped. At that moment, telemetry from Columbia also stopped being received. And all efforts to reestablish communication, they failed. Hemphill, Texas resident Pat Smith was settling down with a cup of coffee when she heard an explosion followed by constant rattling. She ran out and looked up in the sky and saw smoke trails going in every direction. She went back inside and a few minutes later had heard that NASA had lost contact with the space shuttle. It was at that moment that she knew what she had witnessed. During re-entry, superheated plasma was able to penetrate the interior of Columbia's left wing, exposing the shuttle's internal structures to extreme heat. The heat compromised the structures, causing a catastrophic event at 181,000 feet over Dallas, Texas. At the time Columbia broke apart, she was traveling at 11,000 miles per hour. Debris was scattered along a path 250 miles long that rained down over parts of Texas and Louisiana. Along with debris that was once the Space Shuttle Columbia was her crew. And although the exact details of their fate isn't known, they likely remained conscious for a short time after the orbiter began to break apart. And data shows they attempted to regain control of the shuttle for about 40 seconds before it disintegrated completely. Remarkably, a group of tiny worms that were part of a science experiment on board survived the disaster and were found alive weeks later. The debris from Columbia was scattered over a vast area of approximately 2,000 square miles in eastern Texas and western Louisiana. This made the recovery efforts extensive and involved a large-scale, multi-agency operation. Local state and federal government agencies were involved, as well as numerous non-governmental agencies in the search and recovery of Columbia and her crew. 270 organizations in all. The organization and management of thousands of people across all these agencies and organizations posed a significant challenge. Remember, NASA was not willing to rule out any cause, including terrorism or sabotage. And this meant that the 2,000 square mile debris field was treated as a crime scene. When it was all said and done, remains from all 7 astronauts were recovered, along with 84,000 pieces of debris, representing nearly 40% of Columbia by weight. And this included critical components such as data recorders, cameras, and control systems, which were essential for the investigation. Overall, the recovery efforts for the Space Shuttle Columbia was the most extensive and complex in the history of space exploration, involving a coordinated response from numerous agencies and thousands of individuals. As you might expect, the Columbia Accident Investigation Board's findings did not paint NASA in a good light. Their report came to the following conclusions. The primary physical cause of the disaster was a breach in the thermal protection system on the leading edge of the left wing. This breach was initiated by a piece of insulating foam that separated from the external fuel tank during launch and struck the wing. The investigation identified issues with NASA's organizational culture and decision-making processes that contributed to the disaster, including a tendency to minimize safety concerns and rely on past successes. Inadequate communication between different parts of the organization was also a contributing factor, as well as failure to respond adequately to the foam strike during the mission. And it was determined that NASA did not fully understand the mechanisms causing foam loss from the external tank. What, in my opinion, is the most damning finding from the board was the inadequate response from NASA. They said that once the foam strike was identified, NASA did not pursue additional imagery of potential damage and that they relied too heavily on past experiences rather than rigorous analysis. In other words, they failed to learn from history. Could Columbia and her crew have been saved had they known the severity of the damage? Well, we'll never know. We can only speculate. But the fact that NASA never tried is what I find the most disturbing. Look, we all know the story of Apollo 13. Against all odds, the crew was able to take the necessary steps with the help of engineers on the ground to save their ship and return safely to Earth. It's been referred to as NASA's finest moment, and I'd be hard-pressed to make an argument to counter that sentiment. For the crew of Columbia, they were never given a chance to save themselves. In fact, they weren't even told about the foam strike until a week into the mission. Tragic. Space exploration is dangerous business. Space is the most inhospitable environment man can find himself in, and the margins for error are extremely thin. Quite frankly, I'm amazed there haven't been more lives lost. As we mentioned earlier, the crew of Atlantis during STS-27 found themselves in a similar situation to Columbia. A piece of insulating foam struck the underside of the shuttle, causing significant damage to 700 ceramic tiles that make up the thermal protection shield. Fortunately, the crew made it home. One of the more fascinating aspects of that mission was that it was top secret, so not much is known about it. What was known was that Atlantis was to deploy a classified payload on behalf of the Department of Defense. The exact nature of that payload was a secret. The mission was so secret that the launch time wasn't even made public until the day prior. And it wasn't until 5 years after the mission that the crew could reveal even the most trivial of facts. To find out more about this top secret mission that came very close to disaster, click the screen now. And until next time, I'm Dennis Gill for Revealing History.